limited. Okay, so at the high school level, we think that a lot of the research is showing that so many issues with people's math experience is a lack of understanding around ratios. And so, if you've struggled in math a lot of your life, what they've seen is that a lot of it comes down to this understanding right here. And what they see is that when students kind of understand this proportional relationship or ratios, a lot of the other math starts to make a lot more sense. So if it feels a little bit elementary, it's because that's intentional and that we're trying to kind of nip some of those old concepts in the bud in the beginning here so that we can kind of take off more later. And so as we look at this first box here, usually when you come across the notes, these orange boxes are kind of like a big summary of where we're headed or just some definitions. And so basically this first ratio, these 3 bullet points right here, are telling you that a ratio can be written in these 3 ways mathematically. So most of the time we're going to be using the fraction way, but there are some times where the colon or the words, the 3-to-1 is more beneficial. But as a default, I will probably always default to the fraction. So again, most of us did not love fractions growing up, and so if we can kind of understand why the fraction comes to where it is, hopefully the rest of it can make a lot more sense. And that's multiple people asking if they saying they can't hear. I wonder what I need to change. Check my audio real quick. Can I get a thumbs up from a couple people that they can still hear me? Okay. If you can't hear me, I do apologize. Again, there will be a video. So if that's, I don't know what to tell you. I wish I was a tech person to fix it for you, but I am not. You can always leave the Zoom and come back if that's a problem for you. Okay, so as we're writing this ratio, we've got 4 teams in the MLB and 20 did not make the playoffs. Okay, and so if we're writing a ratio, it looks like we're asking for the ratio of the people making the playoffs to the total number of teams. Okay, so out of those 3 bullet points up there, it looks like it's using this 3-to-2 concept there. And so it looks like you're probably never going to actually have to write it out like this, playoffs to total. But a lot of times I like to write the words so that it makes more sense as I'm navigating the situation. And so it's asking you to write it in fractional form. I'm going to write it in all 3 forms just to kind of understand what it's going. So the people that make the playoffs is 4 teams made that playoffs to the total. So if 4 made it and 20 did not, that means that our total is going to be 24. So as I looked at last semester's assignment over this, before this class started, a lot of people wrote 4-to-20, but the actual total is not 20, it is 24. Okay, that total teams is 24. So again, sometimes we kind of get in a rush and we just see 2 numbers and we think we use them just as we see them, but you kind of got to slow down and make sure you're understanding the situations where the 4 comes from, where the 20 comes from. So as we deal with this, you could write it as 4-to-20 like that, or 4-to-24 like that, or 4-to-24 with the colon. And then lastly, you could also write it as 4/24. Okay. It asks you to reduce that fraction. And so reducing our fractions, I usually write it like this. Like I want to look for something that can divide the top and divide the bottom right there. So usually I always start with 2 just because my life is a little bit easier if they're both even. So they are both even. So I'm dividing both the top and bottom by 2, giving me 2 on the top and 12 on the bottom. If you're pretty savvy with fractions, you're probably like, dude, you could have done this way quicker. And I hear you. But again, just trying to make as much sense as I can. So those 2 things are both even again. So I'm going to divide by 2 again in the numerator and the denominator. 2 divided by 2 is 1 on top and 6 on the bottom from 12 divided by 2. So 1/6 would be that final reduced fraction ratio. And if we have to interpret that, we're saying that for every six teams, only one of them is most likely going to make it. If we're looking at like some probability stuff later in the course, but a 1-to-6 ratio would mean that if you have six teams, only one of them on odds are probably going to make it. Okay. Looking at number 2 here, it says we've got 25 of the 100 U.S. senators were women, and we are trying to figure out the ratio of females to male senators. Okay, looking at females to males. Somebody asked points if you will lose points for leaving. No, especially if it's based on tech stuff. Definitely not. Good question. And so male to female. So we know that there's only 25 females. And if there's 100 total senators there, that means only 75 of them are male. So as you can see, both situations here, there might have been a temptation to use the 20 and the 4 and the 100 and the 25, but we got to understand what we're actually asked to do with those numbers. Okay. And so it says, interpret the ratio and what this means. So it looks like for every 25 female senators, there's 75 males, or if we reduce that fraction, 25 to 75, I can divide. Again, you just want to pick a number that can divide both of those. You'll have a calculator, by the way, for your exams and stuff. We'll cover that later. So just like a basic calculator. So don't be too stressed about like having to have your times tables memorized, which is helpful, but not completely necessary. So we're just looking for things that can divide these. I'm going to pick the biggest thing that can, which would be 25. And so it looks like I end up with 1/3. So if I have to interpret that, we're looking at about for one female senator for every 3 male senators when we break it down as much as we can. And I just realized that I did not tell you guys that at the very bottom of all these documents is the answer key. So I'm going to share, I believe I already shared, like you'll have the key and everything, like you'll have my worked out answers as well. Because sometimes I think the bottom isn't enough to really like understand what's happening. Like just having the answer is not always helpful. So you'll get my answer keys of the actual work as well. I'm not trying to like hide anything. I have nothing to hide. It's just math questions. And so give you guys the answers as well as the actual worked out problems as well. Okay. So again, the big thing that we want to be able to do is get the numbered fractions and then also interpret what it means as well. Feel free to ask a question if anybody hasn't. Nobody's in the chat yet, so I'll go ahead and move on in about a minute. I do embed breaks, by the way, and so don't think you're just going to have to listen to me for 2 hours straight. We usually take a 5-minute break after each, like 25 minutes roughly. So we're coming up on a break here in about 6 minutes. So we've got the sub shop, and they've got an 18-inch sandwich. Okay, so I'm going to circle that. And not to be outdone, this rival chain comes out with a 2-foot long sandwich. And how should we write that ratio in order to make a meaningful size comparison? So what your brain should be thinking is like, okay, inches and feet are not the same. So I probably want to write this as either just inches or just feet. So, you can do whatever you want. I think the answer key breaks it into inches, but just for fun, let's just say that 18 inches is 1.5 feet. And if you've got 2 feet, that should be 24 inches. And so you can really write it however you want. Again, I think the answer key does 1.5 to 2, but just for a different comparison, you can do 18 to 24. And so for every 18 inches, they have 24 inches. Or if you divide both of those by 3, you would have 6 to 8. And if you divide that by 2, you would have 3 to 4. So for every 3 inches at the one shop, you have an extra inch of 4 inches in the other shop. You would have gotten the same way there as well. If you had the 1.5, the reason why I avoided 1.5 this year is because if you had the 1.5, if you wrote it as 1.5 to 2, dividing that is a little bit tricky. Like if you had to divide, it's just more complicated in my opinion. And so last semester I actually turned it into 15 to 20 for every 15 feet. There's 20 feet. And so it just got a little bit more confusing. So that's why this semester I just went ahead and went with the for every 3 inches, there's 4 inches at the other shop. So again, still working with ratios here. As we've got this shipping situation, the question that we're looking at here is how much would I be charged for shipping if I spent $44? So if we just take a second to kind of wrap our brains around what the table is saying, it's saying the total amount spent was $12 and the shipping was $1.08. The total amount spent was $29 and the shipping amount was $261, and then the total amount $54, and just the shipping was $486. And so the first question it actually asks before we deal with the $44 is that shipping rate always the same? And so if just on our calculator, if I pull up a calculator, hopefully you should be able to see it. If I just do $1.08 divided by 12, I end up with 0.09. But the question is always, do I divide 108 divided by 12, or do I do 12 divided by 1.08? So if you take a second to think about that, that gives you 11.11111. And so the question that I'm posing to you guys is, should I have written it as 0.09 or 11.1111? Yeah, it was just one repeating. If you didn't remember, you can write that as a 1 with a hat on top of it, telling you that it repeats forever. Really, as long as you're consistent, like as long as you just pick the blue way and do the blue way every time, or pick the purple way and do the purple way every time, you're going to be able to see, okay, if I get different numbers, then I'm answering the question, is the shipping rate always the same? If I get different numbers, then it's not always the same. So it doesn't actually matter what you pick, but I personally like the blue more because it's getting at, for every $1 I spend, I'm getting 9 cents of shipping essentially in that scenario. So if I pull up my calculator again, it'll let me. So I'm going to go ahead and go with the blue way, where I put the shipping on top and the amount on the bottom. 0.09 again. Now the laziness in me doesn't want me to do the third one, but we'll do it just to make sure we're not wrong. 486. So we're on the right track to being the same price. So we'll see if it ends up being the same, which it is. Great. So what it looks like to answer that first question is it always the same? It does look like it is always the same. Shipping price. Check in the chat real quick. I'll answer the text question in a little bit after our break. And then 3.69, I'm not sure what that question is. That might have been, I don't know what that question was referring to. Oh, that might be the answer for part A. Oh yeah. That's the answer for part A. Yeah, we're getting there. And we will actually take our first break after this number 4. So hang in there just a little bit longer. So we're curious, how much would I be charged for shipping if I spent $44? Lots of different ways you could set this up. I'm curious if the person who dropped into the chat did it the same way as I'm about to do it. If I pay attention to the way it's written, it says the shipping rate per the dollar spent, or the total spent, is kind of how it's written there. So if I write that as a fraction, I don't know the shipping or the rate, whatever. I'll just leave it as shipping. But I know that I spent 44, and I need that division to equal 0.09. So that's the way I ended up doing it, where I just, when we divided 1.08 by 12, we got 0.09. When we did 2.61 divided by 29, we got 0.09. And so I'm doing the same thing, but I don't actually know what the shipping is. And so I'm going to replace that with a variable. I'll just call it X. You could have called it whatever you want. And now to get that X alone, since I'm dividing these things, okay, whenever we move things to another side of an equation, I have to do the opposite of division, which is multiplication, or the word inverse works there as well. So I'm going to do the inverse of division, which again is multiplication. I'm going to multiply by 44 on both sides, giving me my answer, which was already dropped in the chat. Thank you for that. Your name, it's Megan. Thank you. And so that is 0.09. We're getting that from 0.09 times 44 to give you X is $3.96. So again, that's the shipping when the total was $44, which is a little bit backwards if you think about it. Oh, no, don't be sorry. No, that's great. I hadn't seen the answer key, so I was like 3.69. I don't know where she got that, but yeah, I appreciate you working out. It's great. I'm going to go ahead and pause this recording. Okay, so this question is asking kind of what I was getting at up in the previous question about, are these all 9 cents for every dollar? And so that question's getting at that again down here, but it's for loyalty points now. So it says for each dollar spent, does it give the same amount of loyalty points? So it looks like the ratio it's asking for is the dollar spent to the points. Okay. So if it hasn't been clear yet, usually this is the spent is that numerator at the top, and then the second part, the points, is the denominator, that bottom. So I'm going to do that for all of these, but instead of writing it with a colon, I'm going to write it with a fraction. And so for this first one, I'm going to do $25 for every 40 points. And then the next one, I'm going to do $80 for every 110, and then $120 for every 205. And so as we look at that, when I get my calculator, if we do 25 for every $40, that's 0.62. If we do $80 for every 110, that is 0.72. So your brain should start to think, okay, I'm going to put that bar on top of it since it's repeating. You should be like, okay, something's weird here. And you're right. As long as you're consistent, so as long as you're using the same parts of division, again, it won't really matter what you actually put on top or bottom. And then this last one is 0.585. I'm going to round that. And so since these are all different, does each dollar spent give the same amount of loyalty points? We do not get the same amount of loyalty points per dollar spent. So again, it's asking how many loyalty points would I earn if I spent $50? You could try to guess, but I believe you can't actually figure it out. And I think the answer key says something like that. yep, I don't know how many points I would earn since the shipping rate is different for each amount. And so something along those lines is it's like not consistent rate, so it cannot be determined. Something like that would be sufficient as you're trying to answer this question when the answer is not specifically. Okay, almost done here. So thanks for hanging in there. We'll take another break close to 7. So thanks for hanging in there. So as we look at this unit price here, whenever we see ratio, okay, we're dealing with those colons, but it's usually just going to be a fraction, okay? Not a faction. I always forget my R when I'm writing. Fraction of a cost per one individual item. So if Kroger is selling this 17.6 ounce bag of Reese's for $6.79, what's the cost? So the dollar per the ounce. So again, whatever is after the per part is going to be in the denominator. So this time, I believe I should have the 17.6 in the bottom because I'm basically matching my units there. So ounces, and then I've got my dollars in the numerator there. And so I'm going to have 6.79. I'll be consistent with my colors, 6.79 in my numerator and 17.6 in my denominator. And so again, the unit here is like dollar per ounce. And so when I divide those and I get 0.3875, that's again dollars per ounce right there. So that's kind of a weird way to say it. So we usually don't talk like that. We would probably say, round that to like 0.39 and say that would be 39 cents per ounce. Something like that is probably more what you would see in the grocery store. So yeah, hopefully that's making sense. Again, if we do the same thing here, if we're looking at the ounces of sesame seeds and the costs, trying to find how many ounces can you get for $1. So this time you can set it up a little bit differently. There's a lot of ways you could do this. If I'm just consistent with the previous question, if I do $4.19 for 16 ounces and I divide those, I believe I get, let's see what we get. 0.26 $2 per ounce. So we could do it like that. I don't really love that way because really what we're saying is that it's 0.262 dollars. So it would be like 0.262 for 1 ounce. And so again, trying to pay attention to my units here that I've got dollars on top and ounces on bottom. Again, you could get there with this way because you could probably set, you could set this equal to $1 with some unknown ounce. You could do it like this. When I send out the answer key, you'll see it done in a different way. Essentially, you just have to divide it the other way, but I don't like teaching it that way because I like to teach it where you have to figure it out. And so, I don't like doing it this way. I think it's a little bit more confusing. So I'm actually going to rewrite it just like I said. So you can check the answer key later too, because it'll be the same thing as I go like this. So again, I don't love this way because we're not really ready for the cross multiplication that's going to happen here. Maybe you are. But I'm just going to do it another way. So you could rewrite this as 16 ounces per $4.19. And when you divide that, that's going to give you some unknown ounce per $1. And so I personally think this way is better. I don't know why I tried to do it the other way, but so when I divide the 16 by the 4.19, you end up with 3.81, however you want to round it. I'll just round it to two places. 3.82 ounces per $1. So yeah, it's asking you to go to the nearest tenth. So that'd be the first place. So 3.8. Yeah. Sorry to go in a roundabout way there. Again, you could do it in this blue way over here, but there'd be some cross multiplication that needs to happen. And I just don't really want to hash that out yet because that's in the lessons to come. So yeah, thanks for hanging in there. So I would do the purple way if I'm going to do this again. So per capita is the next concept it's looking at here, which just means, again, per person. And so if it's per person, that means the amount of people is probably going to be in the denominators as we deal with this. And so this question is saying that there's 188 Walgreens in Indiana, which is definitely believable. There's so many. And the population is 6.8 million. How many Walgreens are there per capita in Indiana? So again, if per capita means per person, it's going to be per people. So if there's 1.86 million people, sorry, I don't know why I said 1.86, 6.8. Side note, if I ever say anything wrong, this happens to me even in like person too. If I say the wrong word, like I said 1.86 or something, trust the thing that I wrote down is most likely correct, but the thing that I said could definitely be wrong. If you've already noticed that and you've been like, dude, this guy is off the wall, I apologize. So if I divide those things, I get some crazy decimal here. Telling me to go to 7 decimal places, which is a little dramatic, but whatever. So 0.0002765. Walgreens. So that number is not super helpful, in my opinion. As we look at the answer key, not a really helpful answer here. It might be better to flip this fraction over and get it the other way. But if we're just responding to the question, for every person, there's only this many of a store. So again, there's not that many stores for each person. So that's why this decimal is so small. And if I'm rounding to 7 places, we've got 1, 2, 3, 4, 5, 6, 7. So if I round that up, that should probably be, they round it down. So I won't count you off if you do round this up to 7, because it's kind of, people disagree on it, which is ridiculous, but I'm going to round that up to 7.7. I know that's different than the answer key, but I always round up when there's a 5, and most people do as well. So last 2 questions here, and then looks like we're at our next break here. So if we look at number 8, again, we've already said that this is not a super helpful number here. And so if it said, how many Walgreens are there for every 100,000 people in Indiana? So again, this is Walgreens per person. So you have a very small amount of Walgreens allocated to you. And so if we did it where we wanted to find out per 100,000 people, if I have 0.0000277 all divided by 1, and I want that to equal something divided by 100,000. So because it's some Walgreens keeping our units consistent per 100,000. What you can do is actually, just like we did in the question before, where that number was in the bottom, you can multiply that number by 100,000. You can multiply 100,000 on both sides. And that will give you the number of Walgreens per 100,000 people. So when I multiply that on both sides, it looks like I get 2.77 Walgreens per 100,000 people. So again, the reason why this didn't make sense up here was because we basically divided by too much. You'd rather see like, okay, for every 100,000 people, there'd be 2.77 Walgreens to serve them. So similarly here, if there's 172 gas stations in Fort Wayne, and our Fort Wayne has that many people, it's asking how many stations are there for every 10,000 people. And so if we just did it by the total first, we're going to get some crazy number because it's just too small. When I divide those, I get 0.00050,146. And again, that's gas stations per one person. And so if that's true, I have to then multiply that by 10,000. So again, the fractional work, which you'll probably never show all this work, which is fine with me. If it's an online assignment, I don't need you to show your work until the tests, which I'll describe how to do that later. So if it's that many gas stations per one person, I'm curious how many gas stations per 10,000 people. And so I just need to multiply by 10,000 on both sides, giving you that there is 5.0146 gas stations per 10,000 people.